Nine. Huh? Good morning. So, in today's session, we are going to talk about IT infrastructure. This is the first episode in our webinar series, Vidyajan webinar series, on IT for non-IT executives. So, episode one is IT infrastructure. In this episode, we are going to learn these five things. We will be discussing computer hardware, what is meant by storage hardware. We'll talk about computer software. Then we'll talk about network equipment. And finally, we'll talk about computer networks. Plus, there will be question and answer near the end of this webinar. So let us begin with the computer hardware. So we talk about computer hardware, there are at least five devices that comes to our mind. One is a supercomputer, which I'm sure everyone must have heard of it. Mainframe is another one, which is also an important computing device. Then there are server machines, also called the large servers. Then there is personal computer, which every one of us use. So I'm currently using a laptop, which is a personal computer, and a smartphone, which again I think more people use smartphone than a personal computer. So it's another important device. So let us understand about a supercomputer. What you see in the photo here is a Frontier supercomputer, which is developed by Hewlett Packard Enterprise, that is HPE. It's also called as the OLCF5. This is the most powerful supercomputer. Who is saying this? There's a ranking called Top 500. They rank top 500 supercomputers, and typically the way they measure the performance is what is used as a flops, that floating operations per second. That is the unit of measure for the performance of a supercomputer. And as of today, HPE's Frontier, which is based in the USA, is the most powerful supercomputer. Now, just to give an indication of what this flops or what the performance would mean. So typical performance of any supercomputer would be more than 10 raised to 17 flops. Okay. Whereas the desktop, which are again very powerful nowadays, would have something like a 10 raised to 11 or 10 raised to 13 flops, right? So you could imagine now how powerful these machines would be. So these are definitely useful for a wide range of tasks which are computationally intensive. I mean, this which requires a heavy computation, right? These are the tasks where supercomputer is useful. So the tasks such as weather forecasting, um, uh, you will see this supercomputer being used. Climate research, oil and gas exploration, molecular modeling. These are some of the fields where supercomputers are used. They are not seen so much in business organizations, but largely used by laboratories and government research labs, and obviously some commercial organization, like for example, the weather company uses supercomputer by IBM, which is obviously required for weather forecasting. Right. The next one is mainframe, and this is used largely by commercial organizations, for critical applications like censuses, which is obviously used by government, but consumer statistics, ERP. So if there are large organizations, they use their enterprise resource planning software, on mainframe. Or you talk about large scale transaction processing. Let us say, for example, RBI is uses kind of mainframe for doing this transaction processing. So all large scale transaction processing that requires a kind of a mainframe. Now, how the mainframes are, why they are so much required in such large scale applications? Because you need high reliability, right? You want to rely on this machine to run 24 by 7. You need high availability. That is what is important. Need to be available round the clock, and it is serviceability. You should be able to service it without taking it down. So this has to run continuously, right? So this is an interesting aspect of mainframe, that it keeps on running. And if you want to do some upgrade, you can do the upgrade while the machine is running. You don't take it down while making any upgrades. Right? So that is what is the characteristics of a mainframe computers. So IBM is a leader here. They have IBM Z series, which is one of the major manufacturer of mainframe. So much so that when people talk about mainframe, they typically refer to as IBM mainframe thing. Though there are many other vendors like Unisys is there, HP Enterprise is there, Fujitsu is there, and so on. But overall market share, the biggest market share is with IBM. Then comes server machines. So many times we think server as a bigger desktop. Okay, so that is what a tower server would mean, which is actually a bigger desktop. So obviously, when you say a desktop, which meant for personal computing, it will have it is optimized or designed in such a way that is used for the end user task, whereas servers are designed more from the server side task. So from that perspective, tower server is something which is looks like a desktop, but it is obviously bigger, much bigger than a desktop. And for small companies which need a kind of a server machine where they will store data, like for file storage or for some application running, they want some server there. So that is where you will see tower server being used for small companies. It's not so widely used, but yes, in small companies where they don't want desktop to be used, which is very small to handle file storage kind of a thing, they may use this tower server sort of it. What is more prominent is the rack server, which is what you see over here, the rack server, and they are rack mounted. So you see these racks, right? This is what you will see in a data center kind of a setup where you have racks and these are mounted on the rack. So they are kind of a rectangular shaped thing and they are mounted uh, on the rack. So it's called rack mounted server or a rack server thing, right? And then there are blade servers, which are smaller in size, and they are not like a full-fledged server. They're modular in structure. So you need a kind of blade enclosure in which you put these blade servers. So this blade chassis, which is what you see the enclosure, it also provides some functionality. So this works as a unit, but it also relies on the shared functionality of the blade chassis. So obviously these are smaller in size, and if there are big data centers, they may use blade servers because blade, as the name suggests, they are smaller in size. They obviously don't look like a blade, but they're definitely smaller in size as compared to rack server, and you can fit in more servers in a given space than rack servers, right? So if you are setting a large data center, then a blade servers makes a lot of sense, right? And obviously you need a blade enclosure also. But if you need few servers, then maybe rack server makes more sense because you just need them. You can have a rack and you can just start filling in the rack with the rack mounted server. Not necessarily that entire rack should be filled in. Whereas typically when there's a blade server, you will take a blade enclosure and put in almost all blade servers over there, and then that makes it more economical if it is used in a larger number. Okay? So that is what we call the types of server machines. Then comes our personal computer. Obviously, we use more of a laptop nowadays than a desktop. But a desktop, you could see there's a system unit, which you see there is a front panel display, a monitor, what we call them. A keyboard will be seen. There's a speakers that are possible. You will have mouse and so on. Obviously, when you use a laptop, you will have a keyboard integrated with the display and entire display and keyboard. Even a mouse functionality is somewhat integrated here, though you may use a mouse separately. The speaker is also built in, the camera is built in. So most of the things are kind of built in laptop, though you may use additional speakers, you may use a mouse and so on, but they are handy. The entire purpose of using a laptop is their mobile. You could take your mobile from one place to another. Desktop, on other hand, are supposed to be stationary. You don't want to kind of move them around. So that's the reason they're a little cheaper than laptop, definitely. But laptops are more widely used than a desktop nowadays. And then comes a tablet. So at some point of time, people thought tablet is what will overrule laptops and laptops will replace their tablets. However, many applications like Excel, for example, requires us to use a keyboard very often. And with tablet, it's a on-screen keyboard, which is not very friendly when it comes to using it for Excel applications. or similar applications, and that is where you will see people still use a laptop. A tab is good obviously for consumer applications like watching movie and those kind of a things, but obviously people use more of a smartphone than a tab. But yes, tab is one of the important mobile device which is being used. Smartphones has become more ubiquitous. You see more of a smartphones. People are almost everybody is using at least one smartphone. I mean, people use more than one. And when it comes to corporate IT, it's still important because people like to watch, see their emails. Nowadays, people use a lot of instant messaging apps like WhatsApp for company purpose and so on. So many apps company has now started putting on their employees' smartphone. So they make a lot of sense as a end user device, and there are many cases where people actually employees in a company actually use only smartphone. They don't have a desktop or a laptop to use. They actually use only smartphone, and that is more convenient for them, for field force, for service force, or for salespeople. The smartphone is kind of a good enough, so that really works well for them. So that kind of talks about that. We talked about server or computer hardware per se. There's also storage hardware. So when you talk about storage hardware, we obviously talk about hard disk, and obviously we talk about flash memory, those kind of a things. But if you really look at storage hardware, you may want to divide them in three categories: primary storage, secondary storage, and tertiary storage. So we say primary storage, it is something which is there on processor or near processor. So something which is on the processor, that is there. There's a processor cache which is there, which is a small memory which is useful. And then there's a RAM and ROM that you would have heard of. Obviously, you must have heard of more of a RAM, or random access memory, which is what we refer to memory. And we say it's a 4 GB RAM, or when you say 8 GB RAM or 16 GB RAM, which is commonly used configuration nowadays, that is what is primary storage. So the data is held in that memory till the machine is on. The machine is switched off, it is flushed out, right? So obviously you want to have something data which is between two sessions on a computing machine. Then you need a secondary storage device. So earlier we used to have more of a hard disk drives, but which are basically replaced by SSDs, solid state devices. So that is something that we have seen. There is also flash memory, the pen drives that we see. So these are what we call the secondary storage. This is also what is called the tertiary storage, which are where we use tape libraries or where we use optical jukeboxes. This is where you are storing something for a very long period of time, right? So when you're putting a long period of time, you don't want to store it on, say, CD and all that. Earlier, that was used to be an option. But as we know, CDs are not that reliable when it comes to storing for a long period of time. So that is where you'll see tape libraries are being used or optical jukebox being used. Most of the time, we are more concerned with what is the RAM in a machine from a personal computing perspective, and the hard disk drive, which is now SSD storage, some storage. So we are referring to primary storage and secondary storage. Very unlikely we talk about tertiary storage. Particularly now with cloud storage coming in, we don't really need so much of a tertiary storage. We store it on cloud. Yeah, but be aware ultimately they may be there are many organizations per se they use tertiary storage. That is for the long term storage requirement. Then let us come to software. So we talked about hardware. Now let us come to software. Now, software, we could talk about five types of software, so to say. The first one is what we call application software, which is what we use as end users, right? So these are general purpose software, could be like word processing, like Microsoft Word, Excel, PowerPoint. These are general purpose. Anybody can use it for whatever purpose they want. They can use to type legal documents, or they can use to type letters, whatever you feel like, right? You can use Word for any purpose, or it could have a very specific purpose. Let us say accounting. There's accounting, there's a HR application, there is a leave and attendance application. These are all application software, okay, and they are basically called as application software because they have some use of it. They're used for something purpose by the end users. On the other hand, we talk about system software. The operating system is an example of it, which is what is used by the system for the system, sort of it. So you use the operating system. So operating system is a very complex software actually. So a software like Windows or Ubuntu Linux or Mac OS, they're actually very complex software applications. They provide an interface to us so that we could, copy the files or compress the files and so on. But internally also they manage hardware resources. So the application software don't need to know about hardware, right? They work with system software, and system software will work with hardware. So you'll have hardware, on top of that there's a system software, on top of that you see the application software. That is a typical way they organize. So application software could be independent of hardware. So application software could be running on a different hardware if there is the same operating system per se, right? So operating system will abstract what we call the hardware resources, and they provide an interface to user as well as other software for using these hardware resources. The third comes a utility software, which are actually supporting other types of software. So things like backup software or data compressor or installers, etc. These are utility software. They are there to help to manage and tune other types of software, right? The other types could be either application software or could be a system software. So installer will be used basically to install application software. So it's is a way utility software. Then there are software development tools. So when you develop new software, right, you need software tools like compilers to translate that, say, Java programming code into machine code, right? So there are compilers. There are different sort of software which are used for development of software, of say system software or for application software. To develop the software, you need some software, which is what software development tools are there. And then there are database management software, which are used for database management. So which means you need to create database, you need to modify database, you need to query database, or you want to control the access to the database. All is managed by this database management software, right? So we could call these the five types of computer software. Now comes what we call the network equipment. So all these what computing machines that we talk about, all the applications we talk about, they all need to be connected, right? Then and then only you will have very meaningful information systems. So the IT could be very useful in organization only if these machines are connected to each other. Now to connect these machines, you will have different types of equipment. So there are actually many. We're just picking up the important ones. So repeater is something which amplifies the signal. So you are connecting, if you want to connect machine A to machine B and they're at long distance, maybe you'll use a repeater in between to repeat basically to amplify the signal. Hub is like a multi-port repeater. So you may have something connected. So you will have a one hub. You might have seen those. If you're in a small organization, you may use hub where you get some signal and you have multiple ports on which different machines are connected, and it actually also amplifies the signals in addition to connecting these machines. Then the bridge is also a repeater with add-on functionality of filtering content. So you may put bridge between two machines, and it will not only blindly repeat, it will not blindly amplify the signal, but it will also look at the kind of content and then filter the content. So bridge is useful from that perspective. A switch is a multi-port bridge. The bridge will connect one to one, but with switch we could have multiple ports, and they obviously will do this content filtering, and they have some buffer, they have some storage of its own. So you could actually boost the performance and the efficiency of the whole thing, right? So that's where the switch are useful. And the router is something which will route things. Now, you router is something which is familiar to most of us because most of us use Wi-Fi router at home. So what a Wi-Fi router does? So for example, there's an optical cable which is coming in our house. It gets connected to one side of router, and on the other side there's a Wi-Fi which is made available. So you can connect your smartphone or your laptops to that router. So router will connect two networks, one which is coming from outside, which is either cable network or optical fiber network, and it is connect gives Wi-Fi network. It also typically have this Ethernet cable uh, thing also which you could use, and that also is useful. So routers are more widely used, and you would have seen at home because of particularly because of Wi-Fi router. And then finally, there is a NIC which is there with the machine. So if you have a computer like a laptop or a desktop, you'll have a network interface card, okay, which could be used to connect the computer to the network. So that is also another kind of a network equipment per se. So we talk about networks. There are different types of networks. The first one is a personal area network, which is where you have a personal computer, your printer, you may connect your telephone with your laptop with via Bluetooth, for example, or you can connect your scanners. You could have some cable going from scanner to machine, or you can connect to the video game consoles and so on. So it's a personal area network, right? It is meant to be very small kind of a network. Local area network or LAN is something I'm sure most of you are familiar with, because that is what you will see. So you'll see these blue cables which are going from one machine to other machine, and these are connecting machines. So they're typically faster. I mean, you could always connect your laptop on Wi-Fi, but if you connect with these cables, you find it a higher speed essentially, right? And this is useful for home, school, office building, or even a closely positioned group of buildings. You could have a one local area network. Campus area network is made of interconnection of LAN. So typically, a college campus, or there is a big facility of a company. You will actually have different LAN in different buildings or different floors of building, and then they are connected to each other. So we have interconnection of LANs, and that is where you look at a campus area network. And finally, you have a wide area network, which covers a large geographical area, say city or country, or even intercontinental distances. So these are what we call a wide area network. So that's all about it for today. So let me quickly do a revision in a sense. What did we look at? So we looked at computer hardware, we looked at supercomputer, we looked at mainframe, we looked at server machines, we looked at personal computer, and we looked at smartphones. Then we talked about storage hardware, which are primary storage, secondary storage, and tertiary storage. Then we talked about five types of computer software: application software, system software, utility software, database management software, right? So all that types of software we looked at. We looked at different types of network, if so on, and we talked about different types of components like personal area network, LAN and WAN and SAN and so on, right? So that's for today. We'll meet next time and we'll talk about the second episode. We'll talk about IT systems. That is episode 2. So we are now with this. Let us conclude this IT infrastructure episode for the time being. Thank you.